Now let's see this example. Let us say this is a non-serial schedule given. S3 is a non-serial schedule given. Now I want to test whether this non-serial schedule is view serializable or not. Now how can I test it? The basic method is using the rules that I have given you earlier. You can write down all the serial schedules possible and you can test whether this one is view equivalent to any of these. Right? If in case if it is view equivalent to any of this, then we can say that it is view serializable, right? Even though it is a lengthy procedure, just for this one example, let's try it. From next time onwards, we shall use other methods. Okay. So for now, just understand the procedure. I want to find out whether this one is view serializable or not. For that reason, I have written all the serial schedules, and now I am checking whether this one is view equivalent to this or not, and then if it is not, then I'll check with that as well. Okay, fine. Now how to test view equivalent? So same method that we have used earlier. Now for A, whoever is writing here first, or whoever is reading here first should read there first, right? Now for A, T1 is reading here first and T1 is reading here first, no problem with that. Now what is the other one? Let's say for B. For B, whoever is reading here first should read there first. Now who is reading here first? B is being read by T1, right? And now here also B is being read by T1. Fine. Now for A, whoever is reading last, now writing last. Now if you see A here, who is writing last? T2, right? Now if you see this side, who is writing last? A. So A is written here and here. Therefore T2 is writing last. And for B, who is writing last here? For B, last write is here, T2. And on the other side also for B, last write is here. So first two rules are satisfied. There are only two data items. Now whoever reads the data item first here is reading the data item first there, and also whoever is writing the data item last there is writing the data item last there. So that is not an issue. Now this third rule says that if there is any write-read dependency, it should happen in the same way. Now if you observe this, what is the write-read dependency is? If someone is writing and someone is reading, see this? Now write of A is being done here, no one is reading here A, and write of A is being done here and no one is reading A. And similarly write of B is being done here, no one is reading here, and write of B is being done here, no one is reading here. Therefore there is no write-read dependency here, right? Now coming to this here, clearly write of A is done here, but there is a read here, which means write and read there is dependency, isn't it? See, so clearly whatever is written by T1 is being read by T2, but if you observe this, T2 is directly reading from the database. It is not reading the value which is written by T1. Therefore, here it failed. So we can say that this one is not equivalent to this one, view equivalent to this one, right? Therefore, but then you cannot here right away say that this is not view serializable. It is not equivalent to this serial schedule, but there is one more serial schedule which you might have to see, right? Okay, now let's test that one as well. Now here you understood that there is no write-read dependency, which means no one is reading anything written by the other. Both of them are reading directly from the database. Now let's see this one here. You can directly go to that point. You need not worry about other points, or you can start with other points as well. Okay. Now what are the first 2 points? First 2 points. For every data item, check whether read is happening in the same way. So who is reading here first? A, T1. Now if you look at the other side, A is being read by T2 first. Therefore it clearly failed. Here T1 is reading it, there T2 is reading it. Therefore this one is not view equivalent to that serial schedule. So with 2 transactions, only 2 serial schedules are possible, and this non-serial schedule is not view equivalent to any of the serial schedules possible. So we can say that it is not view serializable. But then if I have to test it this way for all the schedules, it might take a lot of time. The reason is, see, if you have 3 transactions, then how many serial schedules are possible? 3 factorial, which means 6 serial schedules are possible. And if I have to take every schedule and test whether it is view equivalent or not, then it is going to take a lot of time for me. So that is why we shall see other better methods. Okay, so let's see what is the relationship between conflict serializability and view serializability, and then we shall compare both of them. Okay, we shall see some easy methods. Let's come here. Now, comparison between conflict serializability. If the question is find out whether the schedule is view serializable or not, you found out whether it is conflict serializable or not. Now if it is conflict serializable, you are saying that it is also view serializable. But then if it so happens that if it is not conflict serializable, then still there is a chance that it might be conflict serializable. Got it? So that is where the problem is. So that is the meaning of this point. Every conflict serializable is view serializable, but the reverse is not true. Now the next question is, it is easy to achieve conflict serializability than view serializability. Okay, so I'll show you with examples why it is easy, and it is also easy to test conflict serializability than view serializability. We shall see why it is easy. Okay, with graphs I'll explain you these 2 points. Now how we use it, how we use the conflict serializability to test the view serializability is, first thing is, whenever they ask you for view serializability, now test for conflict serializability, right? Now if the schedule happens to be conflict serializable, then we can say that it is definitely view serializable, right? If the schedule is not conflict serializable, then you cannot say that it is not view serializable. You have to test further, right? So for that reason we are going to use a new concept called as blind write. Okay, so now we test for blind writes. Now if there is a blind write, then we test for view serializable. If there is no blind write, then we can directly say that it is not view serializable. Are you getting this? So how do we use conflict serializability is, first we test whether the schedule is conflict serializable or not. If it turns out to be conflict serializable, then we say that it is view serializable as well. If it turns out that it is not conflict serializable, then you should not directly declare that it is not view serializable. Just test whether there are any blind writes. If there are no blind writes, then you are lucky, you can directly say that it is not view serializable. Now if this is the case, if there are blind writes, then you might have to test whether it is view serializable or not. Now how to test it? You can test using the earlier methods that I have discussed. Write down all the serial schedules, and from that you can test it. But then that is going to be a bit lengthy. So for that reason we are going to use a new graph which is called as polygraph. So using polygraph it will be easy for us to test it. Okay, let's take some examples and see how to draw the polygraphs. Okay, fine.